Hello, everyone. We can get started with the talk. So, the magical Envoy proxy processes millions of connections every day at several companies like Lyft, Google, and Airbnb. But how many of us actually understand what's happening behind the scenes? Let us change some of that today. Hello, everyone. My name is Akshita Agarwal, and today I am here to share some of the insights from my 3-year journey of learning Envoy and debugging some of its greatest mysteries. By the end of this talk, that Envoy config that you've been staring at since 2 a.m., it might feel a lot less daunting. Before we start, I want to mention that everything I share today represents my personal views and experience and not my employer's. So let's begin. Here's a quick agenda for today. We'll start with the fundamentals, understanding Envoy's core architecture. Then we'll trace the complete connection lifecycle, following a connection from start to finish. We'll then explore some of the memory management aspects of Envoy to understand performance implications. And finally, we'll learn some of the best practices you can use while writing your own filters and extending Envoy. So let's jump in with the fundamentals. Here is a very simplistic representation of Envoy. On the left, we have the client or the downstream, which is the one which is sending connections through the Envoy proxy. On the right, we have the upstream or the destination. And in the middle, we have our Envoy proxy. Since Envoy is dealing with these two personas, it naturally follows that within Envoy, we have two major subsystems on a high level. The first one is the listener. The listener subsystem deals with everything related to the downstream. So everything related to how Envoy accepts a connection, maybe performs rate limiting, RBAC, etc., lies within the listener subsystem. You can remember this by remembering on listener helps Envoy listen to everything coming from the downstream. And next, we have the cluster subsystem, which deals with everything related to the upstream. So if you have heard of terms like load balancing protocols or health checking related to the upstream, everything lies in the cluster subsystem. So as I promised you, today we will be looking at this sample config and taking it part by part, understanding what each of the part means. At a very high level, this config has two parts. The first is the listener, which is in this case named as the TCP listener, and it is listening on port 10,000. And this listener has a bunch of config, which includes the filter chain. And next is the cluster subsystem, which in this case we have named it as the Postgres cluster, and it is directing the connection to a Postgres backend endpoint. For today's talk, our focus is going to be mainly on the listener side, as that is where a lot of Envoy's extensibility lies. So, to understand the listener better, we'll understand 4 key components of a listener. The first one is the listener manager. This is the brain of a listener or the orchestrator. It is where everything begins. If you are ever trying to understand Envoy code and reading through a listener, I recommend starting from here. Then next is the star of our talk today, which is the filters. So filters are pluggable components that inspect and transform network traffic. To think of a more real world example, if you imagine an assembly line which is assembling car components, filters are the workstations within that assembly line where each workstation performs a specific task on the payload. Today, we are going to look at two types of filters, the listener filters and the network filters. We'll cover both in detail. The third component is the filter chain, which is nothing but a sequence of filters. Note that whenever you specify a filter chain, the order of filters in the chain is really important, and we will take a look at some examples of why that is the case. And at last, we have the read and write buffers. These are the in-memory buffers in which Envoy reads the data coming from the downstream or the upstream and processes it until it is able to flush the data out to the relevant destination. These buffers are watermarked to prevent memory exhaustion, and we will take a look more in the memory section. So let's begin. The connection lifecycle in Envoy is composed of four high-level phases. The starting of the listener, then which happens every time a listener is updated, and then we have the phase which the three phases which each connection goes through, which is the connection acceptance, data processing, and connection end. So let's start with the listener startup. This is where we set the stage for the connections to happen. So going back to our config we saw before, we have the TCP listener, which is listening on port 10,000. What does this even mean? Uh, so when the listener starts up, Envoy creates a socket on this listener, which binds to the port. This binding results that this socket receives incoming events, and the listener keeps on listening on these events. Whenever an event happens on the socket, and the event on the socket can be anything ranging from connection starting or data incoming or connection ending. For each of these events, a sequence of events get triggered within the listener. So, as I promised, we will look at some of the events happening in the listener when an incoming connection arrives. Starting from the left, this is the Envoy state diagram, which shows the event loop in which Envoy is constantly running. Once the listener has set up the wait on the socket event arrives. And based on what the event is, different things can happen in Envoy. If it is a new connection, we go through the connection acceptance phase. Otherwise, if it is data incoming on an existing connection, we have the data processing phase. And note that this data processing phase happens for each chunk of data that is being processed by Envoy. So this keeps on happening throughout the connection lifecycle. And at last, when the job is done, we go through the connection teardown or the connection end phase. This event loop is really important to understand when you are debugging your connections. So now the stage has been set. The event loop is waiting for events to happen. Let's go through the connection acceptance phase. Here, we have our familiar listener, which is listening for events on the socket. On the left, we have the socket. And once the socket event happens and a new connection is incoming, the listener manager, which if you remember is the brain of the listener, accepts this new connection and it creates a per connection state. And I really want to double click on this per connection state because it is very fundamental to our understanding of connections and debugging. This per connection state is the one in which all our filters lie. And this is a very important design choice. Why? Can you think of why? Why the filters don't need to handle multi-connection? For each new connection, a new filter is initialized. Yeah, you can imagine that this enables so that the filters don't need to handle multiple connections or locking or memory management related to multiple connections. This hugely simplifies our development and understanding of these filters. So now, zooming into this per connection state, we see the first set of filters that we encounter during the connection acceptance, and those are the listener filters. In this case, we have three listener filters, filter 1, 2, and the TLS inspector. The listener filters are the set of filters which run as pre-processing on the connection. For example, they can inspect some of the properties of the connection, like the remote IP, or in the case of a TLS connection, they can inspect the TLS metadata. For example, the SNI. And these listener filters run only during connection acceptance. And once their job is done, they are never invoked during the connection lifecycle. And this is important when you are debugging because the config sometimes looks very linear. Okay, listener filters, then the network filters. But when in real time the connection goes through Envoy, the listener filters only run during the connection acceptance and never after that. Now, the listener filters have done their job. They have inspected whatever data they needed to inspect, and now it is they are setting up the stage for the network filters. The first stage for the network filters is the filter chain matching. Here you can imagine Envoy provides us this flexibility so that based on the properties of the connection, you can configure Envoy differently. For example, if the connection is outbound to google.com, you might want to enforce some configuration. For example, you might want to enforce rate limiting. However, if the connection is to some other website where payment might be involved, you might want to enforce stricter rules. For example, you might want to enforce a RBAC filter. So through this network filter chain matching phase, Envoy helps us to configure different rules for different set of connections. From this, the one of the network filter chains is selected among the ones available in the config, and then the network filters are initialized. From our config, we had three network filters: the IP allow list, the Postgres proxy, and the TCP proxy. These network filters are the beating heart of Envoy, and we will take a look at those next. So now we look at the data processing phase, which is my favorite phase of the connection lifecycle, as that is where a bulk of functionality is delivered in Envoy. As I told you, network filters are the beating heart of the connection processing in Envoy. The network filters they are initialized during connection acceptance and run continuously after that. And they process the actual data that is flowing through the connection. So you can imagine that through these filters, you can look at the data, emit stats, buffer the data, and do a lot of things. Some of the popular examples of network filter include the TCP proxy, the HTTP connection manager, which I'm sure a lot of you must be familiar with, which performs the L7 level processing on the data. And we have the RBAC filter, which again, I'm sure many of the companies are using to enforce RBAC within their service mesh. So going back to our event loop, I want to emphasize the network filters part. As I told, the during the network filters, which are highlighted in the yellow, they run during the connection acceptance phase. Then they are invoked continuously during the data processing phase. And at last, when the connection is torn down, they are invoked again so that you can emit any last remaining piece of stats if you want. And another important call out regarding our understanding of the network filters is about the read path versus the write path. The path of data from the downstream to the upstream is called the read path in Envoy, and the path back from the upstream to the downstream is called the write path. Most of the filters that we know develop are registered in the read path, but if you have any specific functionality you want to do on the write path, you can register the filter as a on the write path as well. For today, we are going to focus on the filters registered in the read path. All right, so we understand network filters at a high level, but to be able to debug connections, we need to understand them in more depth. By understanding the network filter interface, not only can you write new filters effectively, but even you can understand the very complicated network filters like TCP proxy. Everything begins from here. So among the read filters, we have four major methods. And whenever you open the code for any of the filters, you can start with these. The first one is the initialize read filter callbacks. While the name is really big, it is simply a initialization method, and it is very similar to a constructor, which helps the filter get initialized and get all the objects it might need during the remainder of its life cycle. The next three methods, on new connection, on data, and on event, we will look in more detail. So the on new connection is the first method which gets invoked after the initialization of a filter, and it is called exactly once for each filter after the connection has been accepted. But when you look at on new connection, you must know that at, at the time when the on new connection is invoked, no data has been read from the socket yet. This is important because because sometimes you might want to rely on data which you might want to rely on the actual data, but that is not available during the on new connection. But on new connection has access to connection properties like the TLS metadata or the remote or and local IP addresses. Thus, it naturally follows that it can be used for some cases of connection blocking, like IP allow list or deny list, or rate limiting. And the on new connection, as you can see, returns a filter status object which can have two values: continue and stop iteration. And these return values are really important to understand especially in the context of our event loop. So when the filter returns continue, this is the more general case. And continue means saying that the filter is saying to Envoy, hey, I have done what I needed to do. Let other filters look at this connection. This is the more general case you will find in the network filters. And the next return value is the stop iteration. This value is really important to understand. The stop iteration, when a filter returns stop iteration, it means to say, hey, I need some more data, or I need something else to happen on the connection to complete my work. So I don't want other filters to look at it. So stop the iteration right now. And we will look at these values in more detail in the example section. Next, the on data, which is my favorite method of all of these. It is where the real work happens. It's called every time a data is read from the socket, multiple times throughout the connection lifecycle. Some of the common use cases for on data include inspecting or modifying data, connection blocking based on some attributes of the data or the connection, like for example, the RBAC filter, emitting stats on the data, for example, how many bytes are flowing from the downstream to the upstream, and in some cases, buffering the data if you need. And same as the on new connection, the on data returns two values, the same two values, continue or stop iteration. For example, if in the Postgres proxy filter, you need to analyze first 10 bytes of data and only 4 bytes have arrived so far, you can return stop iteration, meaning that you want to wait for more data to arrive. But can you imagine if there is any catch in this? Yeah, if you are stopping the iteration for waiting for more data, but that data never arrived, your connection might be in a stalemate. So, as a developer, you need to be very careful when you're using stop iteration and be mindful of the corner cases that you might have. And last, the on event, which is like a notification bell for the filters. And it's an optional callback that your filter can register if you want. And it enables the filter to be informed of connect state changes on the connection. For example, connection established, or if the connection is getting closed. And this can help you to perform cases like resource cleanup. If the connection is closed, you might want to perform resource cleanup or emit any last piece of metrics or logging, or even perform some error handling if you have stopped the iteration before. So on event is also really powerful. So putting all of this together, let us take a look at a very simple filter. This is the IP allow list filter. And what it does is it simply checks the remote IP of the connection. And if it is not from from a specified list of IP addresses, it closes the connection. So first method, the initialized, as I said, it's simple constructor and provides some of the objects that the filter might need. Next is the on new connection. So on new connection, in the on new connection, as we saw before, we do have access to the remote IP. So we check that remote IP, and if it is a part of our allow list, well and good, we continue the connection. But if it is not, we close the connection and return stop iteration. Next, in the on data, we don't need much work in this filter, so we just return continue. And at last is the on event. And in this case, you can emit stats or emit any logs if you want. So that's a lot, I know. And understanding the network filters is a difficult task. So let us go through some of the examples which might help you to understand the network filters better and put the event loop and all the methods that we saw before in context. So here we have our three filters that we have been looking at in our config: the IP allow list, Postgres proxy, and the TCP proxy. On the left, I have the read buffer. This is the in-memory buffer in which Envoy will read the data coming from the downstream, store it for some time, look at it through the filters, and ultimately flush it to the upstream. To start with, the read buffer is empty, and all the three, at the start of the network filter chain iteration, all the three methods in the all the three filters are initialized. Well and good. Next is the on new connection, and all the three filters, in this case, return continue, meaning that they have done whatever they needed to do. And when the on new connection hits the TCP proxy establishes the connection to the upstream. Next, the first chunk of data arrives. The IP allow list filter and Postgres proxy did whatever they needed to do. Then the TCP proxy is called and the data is flushed to the upstream. And after this, the read buffer will become empty again. Now, when the second chunk of data arrives, the same process continues and our data is continued to be proxied from the downstream to the upstream. Most of the connections that you will see in Envoy go through something like this during the network filter iteration phase. Next is a more interesting case in which the connection gets closed earlier. As from before, the filters are initialized normally. But now, when on new connection is called, the IP allow list filter doesn't like it. It doesn't like the remote IP of the connection, and hence it closes the connection. You can clearly see in this case that the Postgres proxy and the TCP proxy filters are not invoked during this iteration, and the on new connection on them is never invoked. This case helps us understand one very important learning. The filter chain iteration, the filter chain order is very important. For example, if you place the Postgres proxy filter before the IP allow list and waste precious memory and CPU processing the Postgres proxy code, and then you close the connection in the IP allow list, your CPU and memory is wasted. So always try to place the cheaper filter first. This will help you to make your Envoy more efficient. And then since the connection is closed, the connection teardown happens and on event is called on all the three filters. You can clearly see here that in this case, the upstream never goes green. The upstream connection is never established. And the next case we will see is of a filter returning stop iteration. In this case, the initialization and the on new connection happens normally. But now, when the first chunk of data arrives, the Postgres proxy is not satisfied. It returns stop iteration because it wants to wait for more data. In this case, you can see that the TCP proxy is not invoked in this iteration and upstream doesn't receive this data yet. Now, when more data arrives, you can see the old data is also present in the buffer. New data arrives, and now both of these data together are looked at by all the filters. The Postgres proxy filter is happy now. It's able to inspect whatever it needed from the data, and the filter chain iteration continues normally. Cool. So we got through the intense part. Now it's relatively simple to understand the connection end. After the normal data flow is complete, Either of the upstream and or downstream can indicate connection close. And in this case, all the three filters will be invoked again on the on event method with remote close, because it was the remote that the upstream or the downstream which closed the connection. And at last, we have a cleanup phase in which all the memory that was allocated to the connection, all the filters, everything is released back. So, with this understanding of the connection lifecycle, we will explore some of the memory management aspects of Envoy. The first is the per connection memory model that we saw before. So, each connection in Envoy has its own buffers and its own filter instances. This enables so that more the number of connections handled by an Envoy, more is the memory consumed by it. And you can see there is a clear trade-off here, which was made during the design, which is we isolate the filters per connection, but the total memory usage might be slightly higher. But this hugely simplifies our development and understanding of the filters. And you will really thank this design choice when you are debugging a Envoy with multiple threads and multiple connections all at the same time. So in my opinion, this trade-off is worth it. And next is the concept of bounded buffers. In Envoy, the buffer that I showed before, the read buffer and as well as the write buffer, they are bounded. They have a watermark. So if there is incoming data and the buffer exceeds its watermark, Envoy goes into the back pressure mode and it doesn't read more data from that connection. This this is a very good design choice because it prevents memory exhaustion in Envoy from high bandwidth connections. So you can imagine if there are 10 downstream which are sending data through Envoy and one of them is sending a very huge bandwidth, it doesn't affect the others because of this bounded buffers concept. At last, I would like to emphasize some of the filter development best practices that you can use to develop your own filters or even write your own Envoy config. We should try to have one filter with one responsibility. Keeping your filters short and focused on a very specific functionality really helps you while debugging and understanding your filters. Next, always assume that data will come in multiple chunks and test with chunk data. And as I've emphasized before, be really careful when you're using stop iteration. Next, the order of the filters in your filter chain is very important. Try to place the cheaper filters first. And when you're writing your filters, always log the connection ID. It's very helpful. So this wraps up our presentation today. Hopefully, combining all the learning from today, you feel more excited to debug connection issues and develop new filters and contribute back to the Envoy project. Thanks for being with me today. And here are a few useful resources. And you can share your feedback on this QR code if you like. Thank you.
Hello. Hi, I have a question. I noticed when you mentioned the connection close, it's all driven by the event shows like remote close. Is that the event triggered by upstream or downstream specifically? Is there cases like how long the Envoy can kill the connection itself?
Yeah, the connection close can happen from three places generally: downstream or upstream or Envoy itself. So when it is closed from downstream or upstream, it is like we have the remote close event triggered. And when it is by within Envoy, for example, RBAC filter and sometimes TCP proxy, it's called the local close. And you said like you talked about the like connection timeouts kind of thing. So we do have connection timeout. I think by default we have a 1 hour or so of connection timeout and connection idling. So there are several settings we can tune in these network filters to like enable that.
Gotcha. So
Yeah.
when Envoy kill the connection, and that also goes through your events
Yes.
route? Gotcha.
Yes. Yes.
So you mentioned that bounded buffers with stop iteration can lead to a deadlock. Doesn't it have any fail-safe mechanism where does it have a timeout or anything like that to get out of this situation?
Um, Yeah, I did face that situation once. Like, and in the on data, so there are two. You can in your filter, you can handle that in the on event case. Like, generally, what will happen is that if they didn't send the data, either a connection timeout will happen within Envoy, or uh, uh, yeah, like if the connection gets closed out, you can handle it in the on event. But so you can in the on event, you can like trigger the cleanup. Otherwise, the on data method itself gets triggered one last time when the connection closed, and in that the end stream flag is set. So what I was doing was that I was not responding to this end stream flag, and I was just stopping iteration. So this end stream flag also, you can think it indicates that hey, no more data is going to come. So handling that is also critically important.
Okay, so there are
Yeah,
ways
we
to
do
get out.
have. Yes, yes. But we just, when we are writing the filters, we need to be cognizant of that. Yeah. Okay. Thank you. Thank you, everyone.